Hi, this is your Professor Sudha Kolathu Parambil, Section 9.3 Hypothesis Test for a Population Mean Sigma known. We can perform this hypothesis test about mean using the p-value method and the critical value method. Do low-fat diets work? In a recent study, a total of 76 subjects were placed on a low-fat diet. After 12 months, their sample mean weight loss was 2.2 kilograms with a sample standard deviation S equals 6.1 kilograms. How strong is the evidence that the people who adhere to this diet will lose weight on the average? To answer this question, we need to perform a hypothesis test on a population mean. Assume that the subjects in the study constitute a simple random sample from a population of interest. We are interested in their population mean weight loss mu. We know that the sample mean 2.2. We do not know the population standard deviation sigma. But we know that the sample standard deviation S is 6.1. So because we don't know sigma, we cannot use the z-score. Instead, we can use the t-static. So where you will replace the sigma by S. When the null hypothesis is true, the t-statistic has a student t distribution with n-1 degrees of freedom. We describe the student t distribution in section 8.2 when we perform the test using the t-statistic. We call the test a t-test. We can perform a t-test for the population mean whenever the following assumptions are satisfied. That means we have a simple random sample, the sample size is greater than 30 or the population is approximately normal. When the assumptions are met, we can perform the hypothesis test using a critical value method or the p-value method. Now let's see how to compute p-values. The p-value of a test statistics t is the probability, assuming the null hypothesis is true, of observing the value for the test statistics that decrease more strongly with the null hypothesis than the value actually observed. The p-value is the area under the student t curve with n-1 degrees of freedom. Left tail p-value is the area to the left of t. Right tail p-value is the area to the right of t. Two tail p-value is the sum of the area left of negative absolute value of t and to the right of absolute value of t. Assume in an example we calculated the test statistic x bar minus mu 0 s over square root of n. Assume we got that 3.144 and n in the problem is 76. So degrees of freedom is n-1, that is 75 degrees of freedom. So we need to obtain the p-value for this. If you look at the t-table, there is no 75 in the degrees of freedom. So choose a number smaller than 75, close to 75 but smaller than 75. That is 60. Then look at the row corresponding to that and locate the number 3.14. Since there is no 3.14, so you can see the 3.14 is between these two values. So the p-value must be between 0.001 and 0.0025. If the alternate hypothesis is mu greater than 0, then we can conclude that the p-value is small enough to reject the null hypothesis at the significant level 0.05. If we use the alternate hypothesis mu not equal 0, p-value would be the sum of the areas in two tails. The area of the one tail is between 0.01 and 0.0025. Therefore, the area of both tail will be between, multiply these two by 2 This is an example of performing a hypothesis test for a population mean sigma unknown using the p-value method. We all know that generic drug usually cost less compared to the brand name drugs. But in order to sell this generic drugs in United States, it must be tested and they need to prove that it perform equivalently as the brand name product. The US Food and Drug Administration is now supervising the testing of a new generic antifungal ointment. The brand name of the ointment is known to deliver the mean of 3.5 micrograms of active ingredients to each square centimeter of skin. As part of the testing, 7 subjects apply the ointment. 6 hours later, the amount of drug that has been absorbed into the skin is measured. The amounts in micrograms are given. How strong the evidence that the mean amount of absorbed differs from 3.5 micrograms. And the significance level is given alpha equal 0.01. So first we check the assumption. Because the sample is small, the population must be approximately normal. We check this with the dot plot of the data. So 2.6, 3.2, 2.1, 3, 3.1 is between 3 and 3.2, 2.9 and 3.7, and there is no strong skewness and no outliers, so we can proceed. First, state the null and alternate hypothesis. The question says the mean differs from 3.5 micrograms. So the null and alternate hypothesis are mu equal to 3.5 and mu not equal 3.5. Step 2, choose the significance level alpha. Here alpha is 0.01. Now compute the test statistic. T, that is x bar minus mu 0 s divided by square root of n. We know mu 0, we know n, but we need to find the sample mean and sample standard deviation. We can find that using the calculator using this data. Okay. Press Stat, edit. I already have some data, so I'm going to highlight that, clear, enter, then enter the data. 2.6, 3.2, 2.1, 3, 3.1, 2.9, and 3.7. Then press Stat, calc, 1 bar. It will, if I don't enter anything, it will use L1. So since I have L1, if you want, you can enter that. I can see that sample mean is 2.94 and standard deviation is 0.4995. So I'm going to use those values. So the test statistic is T equal 2.9429, I can say, and minus 3.5 divided by S, that is 0.4995 divided by square root of n, so square root of 7. Let me write down the formula again here in case if you forgot. Okay, so that one will give you the value negative 2.951. So this is the test statistic. Now let's compute the p-value. So step 4 is computing the p-value. So here the degrees of freedom is n minus 1, that is 7 minus 1, so 6 degrees of freedom. So if you look at that, that is 6. degrees of freedom and look for the t value. So since there is no negative, we can take the absolute value of t, that is 2.951. So if you look at this row, 2.9 is between these two, right? So these two values. So the p value will be between these two values, which is greater than 0.01. So we do not reject at 0 at the significant level alpha equal 0.01, and we can conclude that there is not enough evidence to conclude that the mean amount of drug absorbed differs from 3.5 micrograms. The mean may be equal to 3.5 micrograms. So let me conclude this. So p value is between 0.02 and 0.05. I'm going to use the next page to interpret the p-value and state the conclusion. Interpret the p-value. So p-value is greater than 0.01. So we do not reject at 0 at 0.01 level. And we can state the conclusion. There is not enough evidence to conclude that the mean amount of drug absorbed differs from 3.5 micrograms. The mean may be equal to 3.5 micrograms. You can also use TI-84 calculator to find the p-value. So in the calculator you will press stat, then test, then t-test, then press enter. Then the t-test menu appears. Then you can either select the stat as input option, enter mu0, x bar, s and n, or you can draw data from the data as the input from the list L1 and it will directly calculate. And alternate hypothesis, you can choose the option like a mu not equal mu0 or less than mu0 or greater than mu0. Press stat, test, use the arrow key, select t-test, press enter. Input, I'm choosing data because we already have data in L1, so press enter. Mu0 is 3.5 and list I'm choosing L1, and we need to check whether it differs, so not equal mu0, so highlight that, press enter, then calculate. So you can see the p-value is 0.025581, which is greater than 0.01. So we do not reject the null hypothesis at 0.01 level. Then interpret the result. Section 9.3 is hypothesis test for a population mean using the critical value method. The critical value method for a hypothesis test of a population mean when sigma is known is same as that when sigma unknown. Only difference is we will be using the student t distribution rather than the normal distribution. Left tail, the critical value will be negative t alpha, right tail critical value will be t alpha, and two tail critical values are t alpha over 2 and negative t alpha over 2. This is an example of hypothesis test using the critical value method. A computer software vendor claims that a new version of their operating system will crash less than 6 times per year on an average. A system administrator installed the operating system on a random sample of 41 computers. At the end of the year, the sample mean number of crashes 7.1 with the standard deviation of 3.6. Can you conclude that the vendor's claim is false? Use alpha equal 0.05 significance level. So 41 computers, that is n. This is the standard deviation, so that is s. And 7.1, that is the mean. So first check the assumptions. So here n is actually 41, which is greater than 30. So we have a large random sample. So step 1 is state the null and alternate hypothesis. So null hypothesis is mu equal 6. Alternate hypothesis is mu greater than 6. We decided the inequality greater than because in the first sentence it says the operating system will crash less than 6 times per year on an average. So we need to prove that it crashes. Alternate hypothesis will be it crashes more than 6 times. So that is why mu greater than 6. Step 2, choose the significance level alpha and find the critical value. Alpha is 0.05. The number of degrees of freedom is n minus 1, so 41 minus 1 equal 40. That's the number of degrees of freedom. This is a right tail test because mu greater than, so this is a right tailed. So the critical value is the t value with the area 0.05 above it in the right tail. So 40 degrees of freedom, alpha 0.05. So T alpha is 1.684. Therefore, the critical value is T alpha 1.684. Now compute the test statistic. So step 3 is x bar is 7.1, mu 0 is 6, s equal 3.6, n equal 41. So test statistic is, this is the formula. Which is equal 1.957. Now determine whether to reject H0. Because this is a right tail test, we reject H0 if T greater than or equal alpha. So here we got T 1.957 and T alpha we got, that is 1.684. So this is definitely greater than T alpha, right? If you compare these values. So we can conclude that we reject H0. So if you are comparing with the diagram, this is the critical region. So T alpha is here and T is in the critical region. Now state the conclusion. We conclude that the mean number of crashes is greater than 6 per year. So in this section you learn the assumption for a test of population mean mu when sigma is unknown, and the assumptions are we have a simple random sample and the sample size is greater than 30 or the population is approximately normal. Then we learn how to perform the hypothesis test for mu when sigma is unknown using the p-value method and the critical value method, and estimate the p-value from the table for one-tailed and two-tailed. Also, I explained you how to find the p-value using the calculator.